shampoo it?
I put conditioner in it.
Okay. Look how soft my hair is. Isn't that soft?
That's really soft.
No, it's baby hair. It says chemo. When it came in, it just came in really soft.
Oh, really? It's not even shampoo, it's just really soft.
It's really soft. Okay. All right, so our books are open. We are looking on page 356 at problem number 33. This you like to be able to fly through. Some of these problems are going to be a little bit of a challenge. We are on 4.1, looking at problem number 33. And I really need you to shut up a minute so we can get this sorted out. Here we go, directions. We have two concentric circles. Remember from geometry that means like a bullseye. These are two concentric circles. We are told that R1 is 11 and R2 is 44. I'm doing problem 33. We're told that, all right, so here's my angle. This arc, the little arc, we are told is 9. And we are going to figure out what the big arc is. Well, I got a couple of different strategies here. Anybody have an idea what we might do? It does say find the central angle, so maybe we should start there. Theta is the letter we use for the central angle. So how could we find that central angle? We could use our formula. What's our formula? Arc length equals the radius times the radians. Now look here at this little piece of pie right here. We call that a sector. Look at this little sector. What do we know about the arc length?
11.
Arc length 9. Radius is 11. And angle is unknown? Not anymore. The angle is 9/11 radians. Okay? Now, let's look at the big sector, the big piece of pie. I don't know what the arc length is, but I know that arc length is what? Radius, which is 44, times the radian measure of the angle, which I now know is 9/11. So the answer is 36. Now, we needed to find the central angle, so I needed to do that work anyway, just for the directions. But does it sort of make sense to you that if the little arc were 9, the big arc would be 36?
Yeah, because 11.
Because what's the ratio of the radii? 11 to 44? So if the radius is 4 times bigger, doesn't it make sense that the arc will be 4 times bigger? So we might have answered that question without finding the angle, but we needed it anyway. All right, next, number 35. To the nearest inch, find the perimeter of a 10-degree sector cut from a circular disc of radius 11. So you got a circle with a radius of 11, and you're going to cut out a sector. Sector is simply the math word for piece of pie. So when we talk about a sector, we're talking about that piece of pie right there. That's a sector. And we know that that is a 10-degree sector. Okay, obviously my picture's not drawn to scale, but that's okay. That's a 10-degree sector. And my job is to find the perimeter of that sector. I think we're about done. What do we need? The only thing we need is the arc length. Won't the perimeter be 11 plus 11 plus the arc length?
Yeah.
Now, arc length is radius times what's the matter? The central angle is in degrees, right? So what am I going to have to do? I'm going to have to change it to radians, which is what you're going to do on your quiz tomorrow. So I choose to say pi is to 180 as something is to 10. And I can find that something. 10 pi over 180. Did you get pi over 18? Now, is that the answer to the question? No, 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 no. That is your central angle, right? So we still have to find the arc. So the arc will be the radius 11 times pi over 18. So I got 11 pi over 18. Is that the answer? No. Remember, you wanted perimeter. So the perimeter is going to be 22 plus 11 pi over 18. And did they give me any units or not? To the nearest inch. All right, I'm going to have to type that in on my calculator. And I will type exactly what it says. 22 plus 11 pi, use your pi button, divided by 18. It's about, did they say nearest inch? It should be 24. Use your pi button, 11 pi. All right, everybody okay with that? Two things on tomorrow's quiz in that problem. One is your arc length formula, and the other is changing your degree measure into a radian measure. All right, 37. It takes 10 identical pieces to form a circular track. If the inside arc is 3.4 inches shorter than the outside arc, what is the width of the track? Whoa, 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 whoa. Wow, that sounds hard. Let's see. So here's my track. Okay, so there are the 10 pieces of the track right there. Here's the track. All right, now what do I know? The inside arc is 3.4 inches shorter than the outside arc. So this would be x, and this would be x plus 3.4. This piece right here. Would you agree with that? Well, oh, wait a second. Do I know how big that angle is? I think I do. Because how many of these are there? 10? And don't I know that the whole thing is 360, or let's do it in radians since we're doing arc length. We'll do it in radians. Remember, a full revolution is how many? 2 pi. And there's 10 of them. So each piece would be a tenth of 2 pi, or pi over 5. 2 pi over 10, pi over 5. ideas?
Find the bigger one first.
So arc length, so x plus 3.4
Pi over time.
equals angle, so that'd be pi over 5, times the radius, and I'll use capital R for the radius. I might as well, can I say x equals pi over 5 times r, and I'll use a little r for the little radius?
Please substitute for x.
Okay, so I have pi over 5 little r plus 3.4 equals pi over 5 big R. Wait a minute, what am I supposed to be finding? What is the width of the track?
What? So we have to find
Okay, now, I'd like you to look at something here. Let's not make this hard enough. Let's not make it harder than it is. They want to know the width of the track. Would you agree that's this right here?
Yeah.
So in terms of the letters that I have on the board, what's this?
Big R minus R.
Big R minus little r. That would be the width of the track. Would everybody agree with that? So let's get these r's on the same side of the equation. So 3.4 equals pi over 5 big R minus pi over 5 little r. Now remember, this is what we want. We don't need to know those radii. We just need to know what big R minus little r is. Any ideas?
Multiply everything by 5.
How about you too? Happy Thanksgiving. Hi, sweetie. Okay, big R minus a little r. Any ideas how we're going to get it?
Multiply everything by 5.
Multiply by pi over 5. If I multiply both, or I mean 5 over pi. If I multiply this by 5 over pi, won't it get rid of these? So 5 over pi times 3.14 will be big R minus little r. And that's the answer to the question. It's about 5.
Yeah. 4.9.
Okay. You guys just did a hard problem. You don't look very impressed, but you did a hard problem. Let's try one. A couple more. How about 39? Oh, compass reading. Yeah, you can do this. This is just to make sure you get how the compass works. Find the angle in degrees that describes the compass bearing of northeast. Now, north, you know where north is, and you know where east is. Northeast is right smack dab in the middle. So what would be the degree measure of that? 45 degrees. That's exactly right. How about northeast? Now, here's north, here's east. This is northeast. You can split this one and you can split this one. This one is called northeast. And guess what this one's called? East northeast. So if we want to know the angle for northeast, it will be 22 and a half. Half of 45. 22 and a half. What's the angle for west, southwest? Okay, now here's west and here's south, so here's southwest.
200.
This would be west, southwest, right? This is the angle we're talking about. Remember, in navigation, you start straight up. So from here to here is 180. This is another 45, and this is another 22 and a half. So what is that? 225 and 22 and a half. 247 and a half. That's easy. Just want to make sure you had that notation in. 43. Any ideas about problem 43? All right, so here we go. Here's my compass point. And one travels at 4230, so here's one of them. The other at 5212, so here's the other one. This whole thing is 5212. If they travel at the same speed, approximately how far apart will they be when they are 25 statute miles? So these are 25. Any ideas about that? Okay, you know Precal socks for no more.
That's what I heard.
Good to see you, Sam.
Yeah, good to see you too. Have a good break.
Okay, angels. What do we do? Kathleen says this distance is really linear, but it's approximated by that arc, right? That arc is really close to being that distance. So basically what I'm being asked to do is find the measure of an arc length. And I can do that very easily if I know two things. What do I need to know? The radius, which I know is 25. And the angle, which would be right here, which would be what? The difference between 52 degrees 12 minutes and 42 degrees 30 minutes. Now I can do that on my calculator. I could also do it by hand. In order to subtract here, I need to borrow, don't I? But remember, when I borrow a degree, I can make that 51, but then this will become a 72. Because when I borrow a degree, I'm borrowing 60 minutes, just like you are with the clock. So that angle is actually 9 degrees 42 minutes. Wait a minute. 9 degrees 42 minutes. That's problematic. Because if I'm going to find arc length, I need my angle to be in radians. So pi is to 180 as something is to 9 degrees 42 minutes. Now I am not worried at all about this because I have a calculator that will give me this decimal. And if I want, I can go ahead and put the pi in there too and get a decimal for the whole thing. Remember, on our quiz tomorrow, you're going to have to be able to put in 9 minutes. So remember how to do that? 9 angle minutes, or degrees, 42 angle minutes. So did you get 9.7? So then we'll divide that by 180. Multiply it by pi, and actually multiply it by 25. And that arc I got to be about 4.23. What about you? Did you get that? And that would be 4.23 miles. So what do we have to do every time? We've got to get our angle in radians, and then if we take it times our radius, we're good. A couple more from this page. Stay strong. See, that's 43, 45. Here we go, 45. Anybody have an idea? What's going on? She's got a bike with 13-inch radius, or 13-inch radius tires. She's traveling at a speed of 44 feet per second. And we want to know how many RPMs, revolutions per minute, that is. Any ideas?
Can we just put it in the calculator?
Well, you can. What would you put in the calculator? 44? And then what?
13?
Yeah, we're gonna need both those numbers for sure. Here's what I'd like you to think about for a second. Let's start with 44 feet per 1 second. That, they gave us that, right? Now, at some point, I need minutes. So I'm gonna multiply this by what? 60 seconds in 1 minute. Would you agree with that? Okay. Now remember, I'm looking for revolutions per minute. I've got minutes down there now. I'm good. I'm not changing that. Now somehow I have to get to revolutions. So let's think about this for a minute. 1 revolution is how far? Now think about it for a second. Here's your wheel. Put a blob of wet paint on it and roll it, white paint, put white paint on it, roll it down the driveway, the blacktop driveway. Every once in a while, won't you see a blob? Every time that thing goes around? And doesn't, every time it goes around, isn't that 1 revolution? Okay, so what distance is that? What is the length of 1 revolution? Isn't it a circumference? And how do we find circumference? 2 pi r? So would that be 1 revolution would be 26 pi inches because our radius was 13? So 1 revolution is 26 pi inches. Now everything's great. I've got revolutions and I've got minutes. But I also have feet and inches, and I can't have that in there. I got to get rid of that. So luckily, what do I know about feet and inches? There are 12 inches, 12 inches in every foot. So what's going to happen to this guy? Gone. What's going to happen to those inches? Gone. Do I now have revolutions per minute? Yep. So I'll type 44 times 60 times 12, and I'll divide that by 26 pi. And when I put that in my calculator, I'm really careful to put the 26 pi in parentheses. Why? because anytime there's more than one thing in the denominator, you have to put it in parentheses. We talked about that last time, right? Okay, we got one more to do. You guys act like there's something wrong with you. You should be excited about all this. Let's look at number 48. Oh, this is on the quiz. We already talked about it. Sketch a diagram of a ship on the given course. What would 35 degrees look like? Here's your compass. What would 35 degrees look like? Right here. This is 35 degrees. Remember, when we're on a course, we are... John, what are you doing? $35 degrees. All right, next, 128. What would 128 look like? About like this? Notice how I'm drawing it with my arrows and things. That's 128. And 310. A course of 310. What would that look like? 310 would be all the way over here, wouldn't it? And this is 310 degrees. Okay, well, you should now be able to do the 4.1 homework. I've just done a whole bunch of them for you. And we have a quiz tomorrow. Now, did you have homework for today? Did you have homework for today? Yes, to memorize the back of that gold sheet, right? Now, if you didn't do that, you want to get that done, because tomorrow we're going to start using those facts. Okay? So get that done. Get started on 4.1. We have a little quiz, half page, just like we practiced. Everybody clear on everything?